Alright, so as I'm covering sections 12.1 and 12.2, I'm really covering them together. That's why I'm writing them at the same time here. Even though your textbook separates these topics, it groups some of these rules together. I'm just going to cover them all at the same time. And then we don't have to worry about splitting this up. Now, one other rule, basic rule, and then we'll get into 3 more complicated ones before we're done. One other kind of basic rule is this one special power of x, just x to the 1 power. Anything to the 1 power is actually equal to itself, right? It's one factor, and you don't have to multiply by other factors because there's only one factor there. And so that's going to be the case all the time. That's actually called the what's it called? The exponent of 1, or the exponent of 1. Okay. All right. So we got the 0 exponent rule, the exponent of 1, the negatives, the product and quotient rule. So now we're going to look at 3 more, a little bit more complicated rules. They're going to be found in section 12.12 or 12.2, and the first one deals with a product of 2 things raised to a power. So something like, 2 times x raised to the power of 4, for instance. So here, in this example, if I wanted to use the definition of exponents, I'd have to multiply 4 factors of 2x. Right? Anything to the 4th power, you have 4 of them multiplied together. Now, because everything is multiplication inside the parentheses and outside, I can rearrange these, right? Multiplication has an associative and commutative properties. And so I'm going to group them together so that all the 2's are together. 2 times 2 times 2 times 2. And all the x's are together. X times x times x times x. So essentially moving things around because they're all multiplied anyway. And what I'm going to end up with is 2 to the 4th power, because there's 4 factors of 2, and x to the 4th power, because there are 4 factors of x. Now obviously 2 to the 4th, we've already seen that one is equal to 16, so I could simplify further, 16x to the 4th. But what's most important is that when you apply an exponent to a product, the exponent distributes to both factors in the product. So you get 2 to the 4th and x to the 4th. So a general rule, and it doesn't matter what these factors are, but a general rule then is called the product to a power rule. And it basically says that if you take x times y, raise it to the m power, you essentially distribute the m to both factors in the parentheses. X to the m, y to the m. Okay. The final, oh no, there's 2 more rules. Sorry, there's 2 more rules. The next rule deals with quotients. And so if I had a quotient like, let's do a over 3 and raise that to the 5th power. Then essentially any fraction raised to a power, again using repeated multiplication, is going to be 5 copies of that thing. 1, 2, 3, 4, 5. So 5 copies of a over 3. All right? And so just like before when we reorganize things, here I'm just going to group things together and just sort of combine all of these fractions together into one. So my numerator has 5 a's, a times a times a times a times a, and my denominator has 5 3's. 1, 2, 3, 4, 5. And so on top, if I wanted to rewrite that in exponent form, it's a to the 5th. On the bottom, it's 3 to the 5th. You can see now that the 5 distributes between the a and the 3. And then, of course, 3 to the 5th can be calculated. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So it'd be 243 on the bottom. Okay. All right. So this rule generally is called the quotient to a power. And it says that x over y raised to the m power is x to the m over y to the m. Okay. Now the final rule we're going to look at involves raising a power to a power. Something like x raised to the 3rd raised to the 4th. Okay, I have a power on the inside raised to another power. Well, let's look at this from the outside. The 4 power means I need 4 copies of x to the 3rd. So 1, 2, 3, 4. That's x to the 3rd, x to the 3rd, x to the 3rd, x to the 3rd. Each of these x to the 3rds is 3 individual x's. So you get x times x times x. Then here I get another x times x times x. Here I get another x times x times x. And this one is another x times x times x. And if you count all these up, there should be 12 of them, right? There's 4 groupings of 3. And so you end up with simply x to the 12th. Notice that the way to get from the original exponents to the final is through multiplication, because you're essentially combining 4 groupings of 3 x's. Okay, that's how we have this split up. And so a general rule for this one, we're going to call it the power to a power rule. And the power to a power rule is going to look something like this. X raised to the m power also raised to the n is equal to x raised to the m times n power. It's a product. So you start with a power to a power and you end with a product of 2 powers. Okay. In the next video, I'm just going to go through some examples of how to utilize all of these different exponent rules.